Okay, in this short video, we're going to just really quickly review using Wolfram Alpha to solve systems of linear programming problems. We're going to start from the actual linear system itself. So what we're looking at here on the screen is a linear system that's already been established. It came from a word problem. Getting to this linear system is going to be your responsibility. We'll talk about that in class, do some other things. But once we've gotten here, entering it into Wolfram Alpha is pretty simple. So suppose I've got this all in Wolfram Alpha. Or excuse me, I've got this all in a system. I'm going to go over to the Wolfram Alpha window and I'm going to just paste it. I'm just going to copy and paste this information. But I got to clean up the syntax a little bit. When I look at this, Wolfram is not going to be able to read what I have here. I got to put it into its language. So first of all, I'm going to delete the p equals. All it needs to know is that I need to maximize this expression, this 4x minus 4y plus 3z business, subject to specifically these guys. It's not going to read the colon, so I'm going to take that out, but it needs a comma between each of the constraints. So after each constraint, I'm going to put in a comma, make sure that it can read what's going on. There's already commas between the greater than or equal to constraints, so I'm going to be fine there. I'm just going to hit enter. All right, after it computes, you're going to see a global maximum box down here at the bottom if you've entered everything in correctly. So what it's telling us here is that if I maximize this system, the maximum value is going to be 70 when x is equal to 10, y is equal to 0, and z is equal to 10. So this information is telling us how to maximize this particular system. Now, keep in mind that it's really easy to screw this syntax thing up. Suppose, for example, instead of putting in maximize, I've been copying and pasting so long that what I actually said was minimize. Check out what happens. So once I've computed, it's going to give me the minimum value at negative 60, right? So negative 60, if this is based on some kind of real world context, more than likely negative 60 is not going to make sense. Even if I'm trying to minimize cost, negative 60 is not a reasonable cost, right? That would normally be positive. And then it's going to give me these values. Well, if I take this as at face value, instead of really logically thinking about what I'm getting here, I'm going to end up with the wrong answer. So just double check your values. Let's say instead that I actually put in maximize, but I left off these greater than or equal to constraints where x, y, and z are all positive. When I hit enter this time, it's going to compute. Sometimes it takes longer than others, but it's going to tell me that there's no global maximum found. And then it's going to give me this crazy contour plot that I probably don't know how to read if I haven't read it before. So this idea is going to tell me one of two things. Number one, there could be no solution. That could happen. Or it could be that I've entered the syntax wrong, which is exactly what's happened. There we go. If I put those greater than or equal to constraints back in, it's going to take me back to the correct solution. So just make sure before you assume that you've entered everything in correctly. Just like your graphing calculator, Wolfram can only do what it is you've actually told it to do in the language that it speaks. So be sure that you speak its language and that you're giving it the information that you think you're giving it. So that's where we're going to leave it for now, but hopefully this has been helpful.